All right, everybody, I'm going to make a quick video on just how to calculate some probabilities using the set deck. This image right here is all of the set cards. So you've got your purple, you've got your green, you've got your red, you've got ovals, squiggles, diamonds, you've got filled in ones, empty ones, and straight, and then of course you have ones, twos, and threes kind of all the way down. So we're just going to go through a couple of probabilities that will hopefully help you guys prepare for your quiz tomorrow. So over here I have three that we're going to start with. Let's just begin with just the probability of drawing one. So I'm going to shuffle all these up into a deck, and I'm going to pick one, and I want to know what's the probability that I'm going to draw a squiggle card. Well, in this case, again, useful for us to know is just some basic facts about the deck. The total number of cards is 81. If you want to count, you can go 3, 6, 9, 3, 6, 9. 9 by 9 is 81. And then if we're going to deal with squiggle, we need to know how many total squiggle cards there are. So the total squiggle cards we've got are all of these, and there are 27 of them. So for my probability is always just the number of desired outcomes, which is of course squiggle, so I got 27, divided by the number of total. So in this case, it is going to be 27 out of 81, which is the same as 1 out of 3, or 33.3%. Cool. So this is what I would call a pretty straightforward probability problem, where it's just how many are there, how many are total. Cool. Okay, next question is going to be the probability of getting a squiggle card and a red card. And in this case, what we're going to look for is we have the total number of squiggle cards here. What I want to also get is the total number of red cards. That number happens to also match the number of squiggle cards. There are 27 red cards right here. And so we can write down two different probabilities that might help us out here. The first one is the probability of red, which is also going to be 27 out of 81, or 1/3. We already have the probability of squiggle just from up here. And if we want squiggle and red, then really what we need to do is we need to take these two probabilities, this 1/3 and this 1/3, and we need to multiply them. So in this case, probability of squiggle and red is going to be my probability of red, which is 1/3, times my probability of squiggle, which is 1/3, and we're going to get a probability of 1 out of 9. Now, nicely, we can actually see this in the table if we happened to split the group up into groups of colors and shapes, right? So like down here I've got red diamonds, here I've got green squiggles. Notice I end up with 9, 1, 2, 3, 4, 5, 6, 7, 8, 9 groups, and one of those happens to be squiggle and red, so that also confirms for us that our probability is 1 out of 9, because we've got one of these 9 groups that is squiggle and red. Okay, third one that we're going to look at is what is the probability of getting a squiggle or a red card, or an oval card, sorry. So in this case, what we need to do is we know our probability of squiggle from up here, it's 1/3. Let's get our probability of oval. It's gonna be the same 1/3, because 1/3 of my cards up here, so these 27 out of my 81 are oval. In this case, what we need to do is we actually need to add the probabilities together, is that we've got 1/3 that are squiggle. We also have 1/3 that are oval, which gets us a total of 2/3 that are squiggle or oval. And in this case, I can highlight those for you. We've got our oval cards, we've got our squiggle cards, and you can see that I've ended up highlighting 1/3, 2/3, and so in this case, my probability is 2/3. Big idea here is when you are getting two things at the same time, you probably want to multiply. If you are getting one thing or another thing, you want to add. Okay, so these are kind of the basics. If you're feeling okay with this, then maybe you don't need to move on. If you are, or actually if you're feeling okay with this, maybe you do want to move on. The next couple, we're going to do a couple that are a little bit more like the yellow cards or the tan cards that you guys had in class today. And we'll try a couple of those. Okay, so the two that we're going to try that are a little bit more interesting is we're going to draw 2 cards now instead of just drawing one. All those last 3 we just drew 1. I want to know what's the probability of drawing 2 diamonds, and then we're going to talk about what about the probability of just drawing 2 different shapes. So these are kind of similar, but there is a difference between them, and we're going to talk about it. Well, the probability of just 1 diamond, if you grab any old card, is just like what we had before. It's just going to be 1 out of 3, or, which is the same, of course, as 27 out of 81. But let's say I draw a card because I need to get 2 diamonds. So let's say I randomly draw this card. Cool. So this card is no longer available. I have taken it out of the deck. Now we got to ask, what's our probability of drawing the probability that my second card is a diamond? And in order for my second card to be a diamond, we just have to ask, with this card missing, how many cards are left in the deck? Well, now there's only 80 cards left in the deck. 80 cards left in deck. And what's the probability, or how many of those are diamonds? Well, we had 27 diamonds. All of these were 27 diamonds. But now we've got 1 less. So now the probability that my second card is going to be a diamond is actually going to be 26 out of 80 because there's 1 less card in the deck and there's 1 less diamond. Now, if I want 2 diamonds, that means I need a diamond and a diamond. So just like before, anytime you have and, you're going to take these 2 probabilities and you are going to multiply them together. So in this case, you would get 27 out of 81 times 26 out of 80. And this right here is equal to your probability of drawing 2 diamonds. So this one where it says, I want just now the probability of drawing 2 different shapes. So any shapes are cool. So the first card, do I really care what it is? Like if the first card is an oval, cool, I got an oval. If the first card is a squiggle, cool, I got a squiggle. If the first card is a diamond, great, I got a diamond. I just want 2 different shapes. So my first card, it can be anything. And so like the probability that I draw a card and it is something is 100% or just 1, or you could call it 81 out of 81 if you wanted. But the probability for my first card, it's like any card will make me happy. It doesn't really matter. But again, now let's pretend like, again, I drew this diamond. Now this time I want 2 different shapes and I have this diamond. Okay, so now in order to get a different shape, my next card, my second card, now we got to think about what am I going to do in my second card. My second card, it can't be a diamond, so cannot be a diamond, not be a diamond. But it could be a squiggle or an oval. So I have all of these other cards to choose from. So now I have 54 cards left over, because if you did 81 minus this 27, that would make me happy. Out of 80 total cards, and again, this is 80, not 81, because I've taken this 1 card out. And so in finishing here, we're just going to take these 2 probabilities, this 1 and this 54 out of 80. So like, I don't care what the first card is. The second card just has to be different than what the first card is. This right here would be your probability for the second one. Hopefully that helps kind of clear up some of those. If you have specific questions about any of the card matches from today, just shoot me an email and I will do my best to walk you through those. Hope you're all doing great.